Okay, so if we start with question 1 then, the question is about atomic structure. In the 19th century, J.J. Thomson discovered the electron. He suggested that negative electrons were found throughout an atom like plums in a pudding of positive charge. And figure 1 shows an atom of element R using the plum pudding model with 7 electrons. The question asks us then to state 2 differences between this model and the model of the atomic structure used today. So the first thing I'm going to do here is just remind myself by drawing it of the actual atomic structure we use today, and we're going to go really simple with our protons and neutrons. Immediately I'm thinking of the differences here. Well, I can see that they're both positioned in the centre, in the nucleus, and then I've got my electrons on the outside in shells. So the thought process of having to draw that has made me identify immediately there the key differences between the 2 models. So I can see for my answer then here, I'm going to be putting that we have protons and neutrons in the nucleus. Now that's really important that we mention both of them. Okay, we're being really specific here. They're protons and neutrons in the nucleus, and we've also got our electrons arranged in shells. We can refer to them as orbitals. We can refer to them as energy levels as well. So it doesn't matter what keyword we're using there to describe that. If we then move down to the next bit, we've got to deduce the full electron configuration. So by this, they're looking for us to talk about the subshells. Okay, so we want to know the full electron configuration of an element of R. Well, I've already highlighted up here that there are 7 electrons. So for this, I have to be able to remember how many electrons fit in each of the subshells and also the order of the subshells. So if I start off with 1, because they go in chronological order, so we start off with 1s, remembering that that can fit 2 electrons, so it's going to be 1s2. Then we've got our 2s, remembering that that can also fit 2 electrons. That leaves us then, because we've said there are 7 electrons in the element R, we only have 3 more to place. So the next subshell is going to be the 2p, and it's going to have 3 electrons in it. Okay, so it's important that here we are remembering the number of electrons that fit in each of the subshells. If I just move that up slightly then, because the next thing, there's quite a few steps to this for only 1 mark really. So we have to start by identifying R. We have to deduce the formula of the compound formed when R reacts with a group 2 metal in the same period. Okay, now it's absolutely vital that I refer to my periodic table. If I can find it, where have I put it? There we are. So, looking at my periodic table then, we've got 7 electrons in R. So we know that R is going to be nitrogen. So that's the first thing I'm going to write down. So R is nitrogen. Okay. We then need to know the formula of the compound when R reacts with the group 2 metal in the same period as R. Well, if I find nitrogen is in period 2, so that means the group 2 metal it's going to react with is Be. So it's going to be N reacting with Be. Now I need to work out the formula of the compound formed when these 2 things react together. So nitrogen, we know has got 7 electrons in its in total, not in its outside shell. But it has got 5 electrons in its outside shell, meaning that when nitrogen reacts, it will form an N3- ion. Okay, because it's going to gain 3 electrons to have a full shell. Be, we know is in group 2, is a little easier, so Be will form a 2+ ion. Okay, so now we know the ions formed for both of our elements. We can identify the formula when these 2 react. Now, if we've got a 2+ and a 3-, we need to balance these out. The best way to get those numbers to fit together is to get them to work out as 6. So if we want 6 pluses, we're going to need 3 Be's. And if we want 6 minuses, we're going to need 2 N's. So our formula for beryllium nitride, I think it would be, our formula would be Be3N2.